give you a different perspective. It's of what I think, what particle physics really means to me, particle physics and cosmology. And that's that I think it's given us a wonderful narrative, almost a creation story, if you'd like, about the universe from modern science over the last few decades. And I'd say that it deserves, in the spirit of Wade Davis's talk, to be at least put up there with these wonderful creation stories of the peoples, the high Andes and the frozen north. This is a creation story, I think, equally as wonderful. The story goes like this. We know that the universe began 13.7 billion years ago in an immensely hot, dense state, much smaller than a single atom. It began to expand about a million billionth of a second. I think I got that right. After the Big Bang, gravity separated away from the other forces. The universe then underwent an exponential expansion called inflation. In about the first billionth of a second or so, the Higgs field kicked in, and the quarks and the gluons and the electrons that make us up got mass. The universe continued to expand and cool. After about a few minutes, there was hydrogen and helium in the universe. That's all. The universe was about 75% hydrogen, 25% helium. It still is today. It continued to expand. About 300 million years, then light began to travel through the universe. It was big enough to be transparent to light, and that's what we see in the cosmic microwave background that George Smoot described as looking at the face of God. After about 400 million years, the first stars formed, and that hydrogen and that helium then began to cook into the heavier elements. So the elements of life, carbon and oxygen and iron, all the elements that we need to make us up were cooked in those first generation of stars, which then run out of fuel, exploded through those elements back into the universe. They then recollapsed into another generation of stars and planets. And on some of those planets, the oxygen, which had been created in that first generation of stars, could fuse with hydrogen to form water, liquid water on the surface. On at least one, and maybe only one of those planets, primitive life evolved, which evolved over millions of years into things that walked upright and left footprints about 3.5 million years ago in the mudflats of Tanzania, and eventually left a footprint on another world, and built this civilization, this wonderful picture. They turned the darkness into night, and you could see the civilization from space. As one of my great heroes, Carl Sagan, said, these are the things. And actually, not only these, but I was looking around, these are the things, right? Saturn V rockets and Sputnik and DNA and literature and science. These are the things that hydrogen atoms do when given 13.7 billion years. Absolutely remarkable. And the laws of physics, right? So the right laws of physics, they're beautifully balanced. If the weak force had been a little bit different, then carbon and oxygen wouldn't be stable inside the hearts of stars, and there would be none of that in the universe. And I think that's a wonderful and significant story. 50 years ago, I couldn't have told that story because we didn't know it. It makes me really feel that civilization, which, as I say, as if you believe the scientific creation story, has emerged purely as a result of the laws of physics and a few hydrogen atoms, then I think, to me anyway, it makes me feel incredibly valuable. So that's the LHC. The LHC is certainly going to write the next chapter of that book, and I'm certainly looking forward with immense excitement to it being turned on. Thanks.